Hi guys, today's notes are on 5.1, simplifying expressions with rational exponents. And our essential question for today is, how can you use a rational exponent to represent a power involving a radical? So the first thing we're going to do is look at some radicals and fraction exponents, just to see what's going on here. Can you please type these into your calculator to confirm? Square root of 9. If you want a cube root or fourth root, you're going to hit math. And just to show you guys, when you hit math, which is right here under alpha, let me clear that out, there are cubes, cube root, and this, which is a nth root, so any number, okay? So in order to use this one, be careful, because if you use this, it takes whatever number you had before. So you need to type the number that you want first as your root, and then type this, okay? Take a moment and confirm that the answers are, try this yourself, 3, 2, 2, and down here, when you use parentheses, some of you guys have calculators that can do exponents perfectly fine. You don't need to worry about parentheses. Some of you guys have calculators like me, where you do 9 to the 1/2, which gives you an answer, and then you do 9 to the 1/2, which gives you a different answer. Okay, so you need to know the difference between these two. Your graphing calculator knows the order of operations, so if you type it without parentheses like this, it does this part first, because we do exponents first, then division, right? So make sure that you use your parentheses to close it off. Confirm that you get 3, 2, and 2 as well. This is not a coincidence, of course, right? These are the same answer here and here. So this is to prove to you that the nth root, okay, the radical root of any number can be rewritten as a to the 1 over n, and vice versa, okay, where a is a real number and n is an integer greater than 1. N is what we call here the index of the radicand. Radicand. Okay. Let's just do a definition. You guys have probably noticed that I write my square roots really funny. You guys have asked before, like, why do you add this line? It's because I know in this chapter that I will be writing numbers on top of that line. And if I don't give myself a little space to write the number, like, let's say 16 fourth root of that, like, that starts to turn into, like, is that an exponent? You guys see the difference? Like, that's going to be a problem moving forward, right? Is that 4 an exponent, or is it an index? So if I wrote x to the 4th and I wrote it like this, you guys see how, like, my 4 is clearly an index and I'm multiplying by x, versus here, it's a little ambiguous if I don't have that multiplication sign, okay? So the index goes above your radical, or in that little space, and then you have a radicand, which is the number inside. So let's talk about real and not real roots, okay? Because if n, or your index, is an integer, which means whole number, we have even integers and odd integers. So let's take a look at why this matters. If I'm taking, say, the third root of -8, that means I'm looking for 3 numbers that multiply to -8. And they have to be the exact same number. So it can be -2 times -2 times -2, which equals -2, right? Because I can take out one of those -2s. That means I have one real nth root when a is positive. Now, if, oh, sorry, negative, what am I doing? When a is negative, I apologize, because it's a negative number. What am I doing? Sorry about that. Okay, now when a is negative for even roots, we need 4 numbers now that multiply to -16. And so let's check. -2 times -2 times -2 times -2, that equals to +16. And 2 times 2 times 2 times 2 also equals to positive 16. So there's no way to get a negative number using 4 of the same number. So there are no real roots. Okay? When a is negative and your index is even. If a is 0, 0 times 0 times 0 4 times, right, is 0. That's 0 times 0 times 0 times 0. Okay, so there's one real root, and 0 times 0 doesn't make a difference for odds either. Okay, and so when this is 0 and 0. What about when a is positive? So let's look over here. I know that to get to positive 8, using 3 numbers is 2 times 2 times 2, and only positive 2 works. So there's one real number, or real root, when a is positive. Can negative work? Negative times a negative times a negative? Has to be a negative, right? So this one is very clear which one is positive, which one is negative. So odd integers, there's always just one real solution. It's when you have an even integer that weird things happen. I know from up here that negative 2 will work and positive 2 will work. So we have positive and negative 2 when a is positive and n is even. So there are 2 real roots. Let's do a quick calculator check though. We did this on the calculator earlier. And just to prove it, if we do 4th root of 16, let's do negative 16 just to see what happens. You see how it says non-real answer, right? Don't just read error and quit out. Non-real tells me that it's not a real answer. Okay, so now let's second enter. I'm going to delete my negative. But it only tells me the positive 2. Okay, so your calculator only shows what we call the principal root. Which is your positive root. Okay. And so you need to know that there's a negative root in there. So here, I guess the question is like, when do I need our positive and negative, and when do we not? Okay, so we know that there's positive and negative roots. And let's take a look and write this in. Find the indicated real nth root or roots of a. So I know that n equals 3, which is my index, and negative 27 is my radicand. And I know, just to show my work today, that negative 3 times negative 3 times negative 3 is negative 27, so my final answer is negative 3. Okay. When we write this one, we have the 4th root of 81. Okay. And so we know that 3 times 3 times 3 times 3 works, but negative 4 times also works because all the negatives cancel out. So our final answer will be plus or minus 3. Okay. Try these yourself. Pause your video, see if you get the same answer. Uh-oh, sorry. Sorry, my lights went out. Okay, now be careful, it's not no real solutions because we're not solving an equation, it's no real roots. Okay. Another concept we're going to touch on is what happens when our exponents are more complicated. A rational exponent does not have to be 1 over, where 1 is your denominator. There can be larger denominators, there can be negative fractions, larger numerators, and there can be negative fractions. And 2 properties of rational exponents are shown below. So one thing to think about when you have a fraction, that a fraction is really a division problem, 1 over something, and a multiplication problem. And so when you reorder this, a to the m over n, you can rewrite it as 1 over n times m, right? And when you distribute in, they become the same. If you separate it where you have a 1 over n, then you can rewrite it as a radical and then simplify the radical and then continue. You should also know that if you have a negative exponent, same thing applies, and you move the whole thing to the denominator, and you can write it as a radical in the denominator. Let's see some examples up here. Before we begin, there are some numbers that you need to know, so can we take a moment, because these are going to be without a calculator problems. Okay, you want to be able to do these without a calculator. And so if you're going to do this, you need to know some numbers. You need to know 4 cubed, 4 to the 4th, 4 squared, 4 cubed, and 4 to the 4th. Okay. You need to know 5 squared, 5 cubed, 5 to the 4th. And you need to know 6 squared and 6 cubed. We probably won't do 6 to the 4th power, and 7 squared and 7 cubed. These are the ones that are like you need to recognize. Okay, so please take a moment with your calculator, write these down. Once you see these numbers, they should be fairly clear. I don't have 6s and 7s memorized perfectly usually, but I can see them and know which one is which. Okay. So pause, write that in yourself. If we are evaluating expressions with rational exponents, what we find is that this is not very helpful without a calculator. But if I rewrite it as a radical, and we write it as the cube root of 8 squared, okay, which is really saying I have 8 to the 1/3 times 2. But I don't need to write that every time. Then I know the cube root of 8 is 2, and then I can square it, and it equals to 4. So let's rewrite this as a radical. The denominator is your index, right? So the 4th root of 256 to the 3rd power. Hopefully you have 256 here. So that's your 4th root of 256 is 4. So 4 cubed, which is 64. Okay. Now, some of you guys are going to ask, why do I not have a plus or minus here? Well, this is a weird distinction. When we had the square root of 20, guys, when we simplified this, and when I simplify this, do I need a plus or minus in my answer? Or is it just 4 times 5, which is 2 root 5? Okay. There was no plus or minus in this answer unless I was solving. Then I need x equals plus or minus 2 root 5. Okay? But when I'm just simplifying the radical, I don't. So when you are simplifying a root, simplify given root, and now we know roots are the same as fraction exponents or rational exponents. There are no positive and negatives. Okay. So when we're simplifying radicals, we do not need fractional exponents. The reason why we needed it here on the front is that technically, this is a very nitpicky one. Basically, don't worry about this because we're not going to write it this way. But because I didn't give you the root in the problem, this is technically not a simplifying a root problem. And so they put in the plus or minus. Okay. So I would just say, for the most part though, simplify, you do not need a plus or minus on any of these problems. When we start solving, then you need the plus or minus. Okay, so let's do a few more examples. Ready? 32 to the 5th root. So root 5 of 32 to the 6th power. You can write it with or without parentheses. They are the same. This will be 64. Oh, I think, question, let's just make it more difficult. What if there was a negative here? What would happen? Then this would become 1 over 5th root of 32 to the 6th power. Okay, so I have to add that negative in over here. And then this would be 1 over 2 to the 6th, which is 1 over 64. Okay. sorry, because I think on your worksheet there'll be a negative, so ignore all of that. Okay, this one we want to stop and think about real quick because this is a little bit tricky. The negative 125 is together under the radical cube root of negative 125 squared. So this one is negative 5 of 125, right? So negative 125 cube root is negative 5 squared. Now be really careful. This is where the parentheses does matter, okay? So I want you guys to know that negative 5 squared in parentheses does not equal to negative 5 squared if there's no parentheses at all. What this is saying is that it's negative times 5 times 5. Because your exponent only gets applied to the very base that's next to it. Okay, and this base is a base of 5. So like technically negative 1 times 5 squared. So you see how this is not the same as here on the left where there's negative 5 times negative 5, which is positive 25. Okay, so please be careful as you do 1 through 8. Okay, so you try please, and let's see what you guys get. Pause your video. Okay, you'll see a few edits in the exponents, which I've already changed on your paper, so just if you're wondering why they're there. The only thing that I think you might have a problem with is this one, number 6. So let's go over that one. We know that it's going to be written as the square root of negative 4 to the third power. Guys, do we know the square root of negative 4 is 2i to the third power? Right? And this is the only one that works. We know that the square root of I is 2i. Or sorry, square root of negative 4 is I. We don't know that the 4th root, 5th root, 6th root, or 8th root, 4th, 6th, or 8th has an I. Okay, this only works for square roots. And if you get this, then you need 8i cubed. And so I cubed is I squared times I, which is negative 1 times I. And then there's an 8. Right, so that becomes negative 8i. Okay. So let's continue. Last 2 examples, and then we're done. To solve an equation now, using nth roots, to solve an equation of the form u to the n power, where equals to d, where u is any algebraic expression, you are going to take the nth root of each side. Okay, and nth root means that it could be the 4th root, the 5th root, the 6th root, the 7th root, right? Any number where n is a number. And when this happens, this is where the plus or minus does come into play, okay? Because we're adding in the radical. Do you see how there is no radical here? And then we're adding it in. When you add the radical in, that's when you have to put in the plus or minus. So now we need plus or minus for even exponents. Yeah, we can do exponents or indexes. Okay. Now, please don't forget all the solving rules we've learned before. You cannot take the 5th root until you get rid of the 4. So we're going to divide by 4, divide by 4. We have x to the 5th power equals to 32. And then you're going to take the 5th root of both sides. And this 5 exponent 5 cancels with the root 5. And we have x equals 2, because the 5th root of 32 is 2. Okay. On these next ones, I'm going to, sorry, this is a 53 on your paper. On these next ones, I am going to just say the steps, but I'm not going to show it because I have less space here. You guys okay with that? So I'm going to subtract 5, subtract 5. So I'll have 2x minus 3 to the 4th power equals to 48. And then I have to divide by 2, divide by 2. So I'll have x minus 3 to the 4th power equals to 24. I'm going to take the 4th root of both sides. And since it's an even exponent and a is greater than 0, we are going to consider positive and negative right here. Okay, so we need a plus or minus fourth root of 24. There is no fourth root of 24, okay, because it's not a whole number. But we can still solve for x. Add 3, add 3. So we have x equals 3 plus or minus the fourth root of 24. Okay, let's go back and check the directions because I didn't read them, so I don't know how I want my final answer to be written. Find the real solution or solutions. Express your solutions as both exact values and decimals rounded to the nearest hundredth. That means two numbers after decimal. Okay, so now I do need to type this into my calculator. I'm going to do one of them with a positive and one with a negative. So let's do this and check. Let me move over. My calculator, sorry, it's a little dark. Let me get the okay. So we're going to do 3 plus 4 fourth root of 24. Okay, that's 5.21. And then instead of typing it all again, I'm going to go second, enter, and then change it to a minus. 0.79. This part, the whole thing, is your final answer. Okay. So you guys try this. Did I change any of the problems down here? No, I've already got those changed. Okay. Try the 3 problems at the bottom and then unpause your video to check your answer. Check your answers and let me know in class tomorrow if you have any questions.